In the last few episodes, the secret to safety kept coming back to one phrase. It also blocks calcium. That calcium is today's star, the calcium channel Cav1.2. It is extraordinary. Block it a little and you save lives, canceling hERG's danger. Block it too much and the heart loses its force. And if a gene jams it open, a child is born whose heart can't reset. One channel, three fates. Why is it so pivotal? Because Cav1.2 does something no other channel does. It turns the heart's electricity into actual force. hERG and the late sodium current from before govern how the electrical signal rises and falls. Cav1.2 is the bridge between electricity and contraction. The instant the heart muscle depolarizes, Cav1.2 opens and a small stream of calcium rushes in. That calcium is modest on its own, but it acts like a trigger. It tells the cell's calcium store, the sarcoplasmic reticulum, to release a big wave of calcium. Only when calcium floods in do the muscle fibers pull, and the heart truly squeezes out blood. This is called calcium-induced calcium release. At the same time, this plateau calcium current holds up the plateau of the action potential. So Cav1.2, a single channel, governs both the electrical plateau and the force of contraction. So blocking Cav1.2 is a double-edged sword. The good edge: with less calcium, vessels relax and the heart works easier. This is the calcium channel blocker that hundreds of millions take for high blood pressure and angina. And with less calcium influx, it neatly offsets the danger of hERG block. Those safe drugs from before, their balanced block leaned on exactly this. The bad edge: too little calcium, and the muscle loses its force and can't pump. This is called negative inotropy. Now, what if Cav1.2 won't close? The calcium channel gene CiPA1C has a class of mutations that strip the channel of its normal inactivation, so calcium keeps pouring in during the plateau. The action potential is stretched enormously, and QT is severely prolonged. This is Timothy syndrome, long QT type 8. It isn't just a heart problem. It often comes with webbed fingers and autism, a rare multisystem disorder, and it's stubborn. Ordinary calcium blockers work poorly against it because the drugs act mainly on the inactivated state, and the mutation destroys exactly that inactivation. Because too much block or too little, too open or too closed, all cause trouble. Cav1.2 became one of CiPA's 3 core channels, alongside hERG and the late sodium current. For a new drug, you don't only test whether it blocks hERG. You test how strongly it acts on Cav1.2, because that calcium can either offset risk or create it. And measuring it, again, comes down to patch clamp. With that, the 3 main channels that decide cardiac safety, potassium's hERG, sodium's late current, and calcium's Cav1.2, are complete. Their push and pull, the net effect, is a drug's true cardiac risk. And the calcium channel is the only one of the 3 tied directly to contraction. When it goes wrong, the heart doesn't just beat erratically, it also loses its force. Next time we look at backup brake. When hERG can't hold, who covers for the heart? The potassium channel IKS and repolarization reserve. Follow Ion Channel Observatory and we'll take them one channel at a time.